The Ratchet and Clank series has a lot of interesting topics that we could cover on the science of gaming. From wondering if the Frankenstein planet from the first game could exist, to the scientific principles behind the hoverboards and magna boots, and at some point I'm sure I'll cover them. But for today, we're going to take a look at something just a bit simpler. Hello everybody and welcome to the Science of, where today we're taking a look at the science behind the Ratchet and Clank series. The Ratchet and Clank games are developed by Insomniac Games, and started with 2002's Ratchet and Clank where the iconic duo first came together. Throughout the 18 years of this game series' existence, there have been many different gadgets used by Ratchet and Clank to help them traverse around the worlds they explore. And although these change from game to game, there are a few which stick around through all of them, with the main one being Clank. I mean, it'd be kind of hard not to have him in a game, his name's in the title after all. In the first game, Clank gets equipped with 3 upgrades which help Ratchet as he platforms around various worlds on his way to take on Commander Quark and Chairman Drek. The first upgrade is the Helipack. This produces 3 propellers out of Clank's head and arms and allows Ratchet to perform 3 moves. The boost jump, which significantly increases the height that Ratchet can jump. Then the stretch jump, which is like Mario's long jump, allowing Ratchet to cross larger gaps. And finally, there's the glide, which allows Ratchet to cross even larger gaps. After the Helipack comes the Thruster Pack, which is basically an upgraded Helipack and is meant to do a few upgraded versions of the Helipack's moves. And finally, there's the Hydro Pack, which allows Ratchet to swim fast through water. Honestly, it's probably my least favourite upgrade throughout the entire game, as it's only used a couple of times. And as well as this, it's kind of useless without another piece of equipment, the O2 mask. For the purpose of this video, we're going to take a look at the Helipack, and see if it would actually be capable of carrying Ratchet and Clank over rooftops, as shown in game. In order to figure this out, we need to understand how helicopters work and why we're able to fly using propellers. The key word of this entire topic is lift. In order for anything to fly, it must have lift, a force which acts against gravity and moves the object upwards. With helicopters, its rotating blades are wings which create lift. These wings produce lift because of a relationship called the Bernoulli principle. The Bernoulli principle states that the speed of air and the pressure of air are inversely correlated. This means that the faster air moves, the lower its pressure. Wings can use and manipulate this principle to create lift. Air travelling over a wing normally has a greater distance to cover than the air moving beneath the wing. This means that the air on top of the wing travels faster in an effort to keep up with the air travelling beneath the wing. This increased speed above the wing causes the air to have a lower density, and consequently this means that the air above the wing also has a lower pressure. This means that the helicopter's blades get pushed upwards by the high pressure air below them. Okay, so in order to see if Ratchet and Clank will be lifted, we need to know what kind of weight we're going to be lifting. So we'll need to know the combined mass of both Ratchet and Clank. Fortunately, we can get Ratchet's weight pretty easily. Ratchet Gladiator, otherwise known as Ratchet Deadlock in America, states his weight as 97.5 pounds or 44.3 kilograms. Clank, on the other hand, weighs only 17 pounds or 7.7 kilograms. So together, they weigh 52 kilograms exactly, or around the weight of an adult North Pacific giant octopus. Okay, so now we know the mass we're trying to lift. Let's see if Clank's propeller will produce enough lift to allow him and Ratchet to glide gently, rather than just plummeting straight onto an unsuspecting Kawan resident. In order to do this, we'll use the helicopter lift equation. This will tell us what kind of force Clank can produce to act against gravity. In this equation, L signifies the lifting force, and this is what we need to compare against our hero's weight to see if the Helipack could lift them. P signifies the air density, which for the purpose of this video will be Earth's air density, which is 1.27 kilograms per meter cubed. V is the true airspeed, which means the speed of the helicopter blades into the oncoming air. This is easy enough to figure out, but first we need to find our circumference of the blade's path. This means we need to know the length of Clank's propeller blades. We can get this from the cutscene where Clank first gets his new upgrade from Big Al's Robo Shack. From this, we can see that the total length of the blades are roughly 1.8 Clanks tall, or 1.08 meters in diameter. From here, it's easy to work out the circumference of the blades, as circumference equals pi times diameter, which gives us 3.39 meters. So now that we have the diameter, we can figure out the angular velocity of the blades, which will be equal to their air speed, and that's the speed that the air will experience from the blades. In order to get this, we need to know the number of revolutions that the blades experience in 1 minute. 1 revolution changes the angle of the blade by 2 pi radians or 360 degrees. So then you just multiply the number of complete rotations in 1 minute and divide it by 60 to give the angular velocity in meters per second. The blades on Clank's propeller revolve at a speed of 2 rotations per second. And I don't think I need to tell you that's an absolutely pitiful airspeed. 2 rotations per second gives us 120 rotations per minute. This multiplied by 2 pi radians gives us 753, which we then divide by 60 to give us our angular velocity of 12.56 radians per second. So now we just need to work out the linear velocity, which is going to be the air velocity. All we need to do for this is multiply our angular velocity by the radius of the blade, giving us our final air velocity of 6.79 meters per second. A is the surface area of the helicopter blades. This refers to the general surface area of the helicopter blades, and obviously the bigger the better, because the bigger the blade is, the more air you push down and the more lift you produce. Figuring this out is once again relatively simple. All we need to do is half the diameter we found earlier to find a radius, then perform pi times radius squared to get the area, which in this case is 0.91 meters squared. That's a pretty damn small surface area, and it definitely won't be producing much lift. And finally, we have CL, which is the dimensionless lift coefficient. This is the angle between the helicopter blade's chord line, an imaginary line drawn through the middle of an aerofoil extending from the leading edge to the trailing edge, and the oncoming air. The aerofoil is effectively the cross-sectional shape of any wing or helicopter blade, and its shape will determine how much lift the helicopter will be able to produce. Unfortunately for Ratchet and Clank, their aerofoils are looking pretty flat and aren't angled at all, so this is really going to limit the amount of lift they'll be able to produce. Using software called FoilSim, which I'll link in the description, I found that a flat plate like this would have a lift coefficient of 0. This means that the Helipack would not produce any lift at all to Ratchet and Clank, but luckily for us, it doesn't end there. As well as the Helipack from the original trilogy, there's a Helipack from the Ratchet and Clank Future trilogy, which started with Tools of Destruction and ended with Ratchet and Clank Into the Nexus. This Helipack seems to not be a solid plate like the original, but instead an oval-like cross-section. Putting this into the FoilSim program, we find they would have a lift coefficient of 0.64. For the purpose of this calculation, we'll keep all of our values the same besides the lift coefficient. From this, we find the lifting force generated by our Helipack to be 17.05 newtons. That's disappointing. For reference, a helicopter that weighed 700 kilograms would require 6,867 newtons of lifting force just to hover at a constant altitude. So things really aren't looking good for Ratchet and Clank. So now we have the upward lifting ability of the Helipack, all we need to do is find a resultant force of this action. The Helipack produces 17.05 newtons of upward force, and the force that Ratchet and Clank have on the Earth would be 510.64 newtons in a downward direction. This means that there would be a resultant force of 493.59 newtons acting downwards. This means that even with a better aerofoil, the Helipack just wouldn't have enough upward force to lift Ratchet and Clank off the ground. It wouldn't even be strong enough to lift Clank on the ground on his own. So now you might be wondering, what would be needed to make the Helipack work like it does in game? Well, there are a ton of options, and all of them have to do with our lift equation. First of all, we could increase the speed that the blades rotate. The increase in the airspeed would increase the difference in the air pressure above and below the blades, creating more lift. Next up, we could simply increase the size of our blades. Increasing the radius of the blades would also increase the surface area, meaning that more air would be pushed away from the blades, creating a larger cushion to support our dynamic duo. And finally, we could change the lift coefficient of the blades. The greater the difference in the distance the air takes over compared to under the blade results in a greater difference in the air pressure above and below the propeller. This can be done in two ways. One, by increasing the curvature of the blade, and the other, which is to change the angle of the propeller's blade. Increasing the angle of attack on the blade results in a longer distance for the air to travel over the top of the propeller, leading to the air pressure above the propeller being even lower than below the propeller, creating more lift. The one thing we can't change is air density. This is set by the planet you're on, but it can be slightly altered with the altitude you try and jump on. So there we go. Clank's Helipack is pretty much useless. and definitely would not be able to do any of the heavy lifting it does in game. In fact, it might be better for them just to lose it and jump normally, as the extra weight is most likely going to make it harder for them to jump. Thanks for watching. If you enjoyed this video, then don't forget to like and subscribe. And if you have any particular scientific subject or game that you'd like to see me cover in future, then please tell me in the comments down below. But until then, this has been the Science of Ratchet and Clank. I'll see you next time.